In this video, I will show you how to use graphing calculator to figure out the volume by rotating across the y-axis. There are two methods to figure out the volume by rotating across the y-axis. One is called the disk method. The other is a shell method. First of all, let's talk about this shell method. Suppose here is the shaded area rotated across the y-axis. Then from this solid rotated across the y-axis, we can take a very thin cylinder. For this cylinder, you can imagine it's a printer paper. As you know, we can fold a printer paper into a cylinder. But when we make it a flat, we will get a rectangular. It's just very thin. The thickness is use dx stand for that because it's a very, very thin. So the volume of this rectangular, we can figure out the length equals 2 pi r. The r will be the x coordinate. Thickness, think about this is a piece of paper, printer paper, very thin, so we use dx stand for that. The height will be the f of x because for this shaded area is on the x-axis. So the volume, we can figure out that equals 2 pi times definite integral from a to b x times f of x dx. The radius is x, and from a to b, this interval is x value. What if the shaded area not bounded by x-axis? Like this one, the area bounded by two functions. You want to use the shell method. Then you need to figure out which one is the upper function, which one is the lower function. The height will be the difference of these two functions. So you got to use this formula. In other words, when the shaded area not bounded by x-axis, but it's rotating across the y-axis to form a volume. When you use a shell method to figure out the volume, the height will be the difference of two functions. So this will be the formula. Let's go to the example. Find the volume of the solid formed when the following are revolved through 2 pi about y-axis. Look at this graph. This is y equals x squared plus 1. For x is between 1 to 4. So for this shaded area, we'll rotate across the y-axis to form a solid. So when we want to use a shell method, how to figure this out? If we want to use a shell method to figure out the problem, we know the shaded area are formed by two functions. One is y equals x squared plus 1. The other is y equals 2. So we have f of x and g of x. G of x will be this 2. Think about this very thin rectangle rotating across the y-axis to form this cylinder. When you open this cylinder, you will get this rectangular. So for this rectangular, the volume will be length times width times height. Length will be 2 pi x. Basically, it's 2 pi r because the r equals x. That's the reason we got 2 pi x. The thickness is dx. You think about this is a piece of paper. Then the height, it is the difference of these two functions. So you have f of x minus 2 because y equals 2. This is the height. It's the difference of two functions. Therefore, the volume equals the integral from 1 to 4, 2 pi x. For the rectangular, the height will be f of x minus 2 because the shaded area is formed by two functions. Y equals x squared plus 1 and also y equals 2. Now I will show you how to put this into a graphing calculator. First of all, we will put the f of x, that is x squared plus 1 put into y equals. We will get the x squared plus 1. Then we quit. We will put the 2 pi first. Then math 9 from 1 to 4. Then you put here is x times parentheses alpha trace y1 minus 2. Then we put here is dx, then enter. This will be the solution. For this question, you can also use washer method. Basically, it's a disk method. So if you want to use a disk method to do that, you will use this graph, y equals x squared plus 1 and x equals 4. We will think x equals 4 is an outer function, but x equals 4 is not function, so we say x equals 4 is an outer equation. The inner equation will be y equals x squared plus 1. So we will use pi times integral. Remember the interval will be y value. So for domain x greater than equal to 1, less than equal to 4, if you plug into this x squared plus 1, you can get the range for y value will be between 2 to 17. That's the reason here you get 2 and 17 here. R squared for x equals to 4, this is an outer equation. The r will be 4. So we get the 4 squared minus x squared. For x squared, you will solve for x first. You will get x equals the square root of y minus 1 because x is positive. Then you will put this into graphing calculator, compare the solution we got from shell method. Now we will put this into a graphing calculator. Go to y equals. For y2, we will put the second x squared, that's square root. We will change every single y into x. So here is x minus 1. Then we go to quit. So we will do pi, then math 9, from 2 to 17. This will be 4 squared minus alpha trace. This time it's y2 squared. Then dx. Enter. You will see you get exact the same answer. Let's go to another example. Y equals the cubic root of x minus 2 for x is between 3 to 10. Just look at this graph. The shaded area will rotate across the y-axis. Then we need to figure out the volume of this solid. We will use the shell method. If we want to use shell method, you need to figure out the volume of that rectangular. Think about this is a piece of paper. So what's the volume of the piece of paper? You will see the radius is x. So 2 pi x will be the length of this rectangular. The thickness is dx. The height, it will be f of x minus 1 because the shaded area is formed by two functions. One is y equals cubic root of square root x minus 2. The other is y equals 1. That's the reason we will change g of x into 1. Therefore, we can write down the volume equals definite integral from 3 to 10, 2 pi x, y minus 1 dx. Now I will show you how to put this into a graphing calculator. We will go to y1, go to math. You could say for 4, that's a cubic root. So I will press 4. Then I will do x minus 2. Then I quit. I will put the 2 pi first. Then go to math 9. From 3 to 10. X times alpha trace y1 minus 1. Then here's dx. Then enter. You will get the answer to this question.